As on Earth, the sky has a coordinate system that allows us to locate objects such as galaxies and stars. To locate deep sky objects, we use right ascension and declination. Right ascension is comparable to longitude on Earth, and declination in the sky is the same as latitude. RA is quoted in hours, minutes and seconds, and declination is quoted in degrees, arc minutes and arc seconds, all of which are angles. For example, Polaris has a right ascension of 02 hours, 31 minutes and 458.7 seconds, and a declination of 89 degrees, 15 minutes and 51 seconds. This grid is at an infinite distance away from us, and the Earth lies at its centre. The north and south poles of this grid line up exactly with the Earth's north and south poles. There are many different types of celestial objects, ranging from planets to black holes. 3 major planets that can be seen through the telescope are Mars, Jupiter and Saturn. When you image Mars, you can sometimes see the polar ice caps and some surface detail. If you image Jupiter, you will undoubtedly see its definitive stripes, the giant red spot and occasionally a moon or two. If you image Saturn, you will see its magnificent rings, which separate it from the rest of the planets. Asteroids are exciting to observe, as you can see them move against the stars in the night sky. And who knows, you may even discover an asteroid that is on a collision course with Earth. Stars are huge chemical factories that create all the elements up to iron. When stars that are similar in size to that of our own Sun die, they turn into novae and eventually planetary nebulae. At the centre, you can typically see the white dwarf left from the death of the star. If a star more than 10 times bigger than our own Sun dies, then it goes supernova, and other elements heavier than iron are created. These huge explosions leave towering clouds of dust and gas where new stars are formed. All these objects are held in vast galaxies that can be up to 100,000 light years across. Having telescopes placed all over the world means that objects in the night sky are observable 24 hours a day. If you are in the UK, during the day you can operate telescopes in Hawaii and Australia. And with strategically placed telescopes, the night sky can be continuously observed. This is great for time-critical events such as NASA missions and other naturally occurring events. The weather is something that we cannot control, and this can be a big problem for astronomers. Some types of astronomy require perfect observing conditions, but this is not always the case. When doing observational astronomy, it is important to have a clear sky, but this is frequently not the case. Bad is not always dictated by the cloud cover, however, but also by disturbances in the atmosphere due to convection currents. This is known as the seeing. Here is an image where the seeing is not so good. The image appears blurry and dull with very little detail. Here you can see the same image taken with good seeing conditions. There is much more detail and definition. The moon is a beautiful sight, but not to all astronomers. The moon can cause real problems when carrying out observations. Just as the sun causes the sky to turn blue due to Rayleigh scattering, the moon does too. This image, taken during a full moon, looks faint and uninspiring. If we split the image into its constituent parts of red, green and blue, we can see that in the blue image there is hardly any trace of the galaxy. In the green there is a little more detail, but in the red you can see much more detail. So when observing during a full moon, it is probably wise to only image in the red. Although you can get some very good images of bright objects such as nebulae, galaxies and planets.